Steps involved in solving Nernst equation. First one, write the cell reaction. Second step, write the cell representation. Third one, find out anode and cathode of the cell reaction. Step 4, calculate standard reduction potential, that is E naught of the cell. Solve the log part separately and substitute in Nernst equation. Calculate EMF of the cell in which the reaction is Mg plus 2Ag plus gives Mg2 plus 2Ag. Magnesium concentration given, Ag plus concentration is also given, and E naught value of magnesium and Ag plus that value is also given. Here one thing you have to note down is Mg2 plus ion is in the product side and Ag plus ion in the reactant side. But the concentration of Ag plus is twice. So 2 Ag plus, this part you have to remember. Next following steps we are going to use. So reactants, product side Mg2 plus ion is present. This part is very important, and Ag plus is present in the reactant side. Ag and Mg we are not going to involve these concentrations in problem because they are in the solid state. In solid state, concentration becomes unity. This part you have to remember. Next is writing the chemical equation. Mg loses electron and loses 2 electron and becomes Mg2 plus. That 2 electron will be taken up by 2 Ag plus because 1 Ag has only one positive charge. But magnesium is giving 2 electrons. So 2 Ag plus gains 2 electron and changes into Ag. Electron you can cancel. Just you can add these. Magnesium plus 2 Ag plus in the reactant side. Product side Mg2 plus Ag. Next is cell representation. The element which loses electron should be written in the left hand side. Mg loses electron and becomes Mg2 plus. Double parallel line, that is salt bridge. And then Ag plus, it is not Ag2 plus, Ag plus bar Ag. Ag plus concentration is given. And this is the left hand side, whatever you write in cell representation, that act as anode. And then double parallel line, that is salt bridge. And the right hand side you have written the cathode. So anode, salt bridge, cathode. So this technique is nothing but ABC technique. A is anode, B is salt bridge, C is cathode. Next is calculation of E naught of the cell. E naught means standard reduction potential of the cell. Formula is E naught of cathode minus E naught of anode. E naught of cathode will be always a highest value. E naught of anode will be lowest value. So we have seen that which is anode, which is cathode. From the ABC technique you know which is anode. Silver is cathode, magnesium is anode. So corresponding values are given in the problem. Just substitute, minus will become positive. So just these two values if you add 3.17, that is the E naught value. Next, substitution in the Nernst equation. Nernst equation is E cell is equal to E naught minus 0.059 by N log of products by reactants. This is the Nernst equation. So here we are substituting E cell is equal to, previous step we have found out the E naught of the cell. Substitute the value 3.17 minus 0.0591. Number of electrons, zinc is losing 2 electrons, silver is gaining 2 electrons. So total number of electrons involved is 2 into log of products concentration is, I already told in the second step. That is, you have to remember Mg2 plus in the product side. So concentration of Mg2 plus is 0.130 and silver is concentration is twice of Mg. So there also I have told in front of Ag plus you have 2. So the whole concentration power 2 has to be written for silver. So 3.17 minus 0.0591 by 2. So this log value separately you solve. Log multiplication means log you have to add. Log of 0.130 plus log of 10 power minus 8. Log of 0.130, log book you have to refer the value 13 and 0 you have to see. So that you have to find out for log 130. log of 10 power minus 8. Power rule, using the power rule, minus 8 will come to the front. Minus 8 log 10. Log 10 value is 1. So minus 8 into minus, that will become positive. That is why here 8 is written. 8 minus 0.866 volt. So when you solve all this, the final answer is 2.96 volt. Another problem, determine the EMF of the following electrochemical cell. Zinc for zinc 2 plus, double parallel line, copper 2 plus for copper. See here cell representation is given, very easy. So the zinc is anode, copper is cathode. That is ABC technique. So zinc is anode, copper is cathode. Okay. We will also write the chemical equation. Zinc loses, being an anode, this loses the electron, zinc 2 plus 2 electron. So reduction, first is zinc to zinc 2 plus oxidation. Half reaction happens. Copper 2 plus gains 2 electron gives copper. Here reduction half reaction is copper 2 plus gains 2 electron given by zinc and changes into copper. Electron you can cancel. So the overall reaction is zinc plus copper 2 plus changes to zinc 2 plus copper. Here number of electrons involved in this reaction is 2. N is equal to 2. Anode is zinc and cathode is copper. Smaller value for reduction potential indicates that anode is zinc. Larger value of E0 value indicates that cathode is copper. So E0 values are given. Next is calculation of E0 of the cell. E0 of cathode minus anode. Cathode is highest value, that is 0.34, copper value. Lowest value is zinc minus 0.76. So E0 of the cell is 1.10 volt. Then write the Nernst equation. E is equal to E0 minus 0.059 by N log of anode by cathode. So product by reactant. So E cell is equal to E0 of the cell we have found out 1.10 minus 0.059. Number of electrons involved in this reaction is 2. And then you have to solve the log value. Log of 0.0001 by 0.1. So when you solve this, you will be getting minus 3. So when you substitute, the final answer will be 1.885 volt. Concentration log of 0.0001, that is 10 to the power 1 digit 10 to the power minus 1, 2, 10 power minus 3, 10 power minus 4. So numerator will be 10 power minus 1, denominator is 10 power minus 1. When minus 1 goes to the numerator, it becomes 10 power minus 3, minus 4 plus 1, so 10 power minus 3. So log of 10 power minus 3. So using the power rule, minus 3 will come to the front, minus 3 log 10. Minus the log 10 value is 1, minus 3. So that is why here we are writing minus 3. Final answer is 1.1885 volt. Question number 3. The standard reduction potential of three metals ABC are given as 0.5 volt, minus 3 volt, minus 1.2 volt. The reduced, if E0 value is less, the element loses electron. It is said to be oxidized and it can act as a good reducing agent. If E0 value is more, the particular element gains electron. It is said to gain electron as well as it can act as a very good oxidizing agent. E0 value is equal to minus 3 for B, E0 value minus 1.2, third one E0 is equal to 0.5. So very less value is for B and then C and then highest value is for A. So very good reducing agent is B, then followed by C, followed by A. So first option is the correct option. Reaction is Ag plus E electron gives Ag and then another Cu2 plus 2 electron gives Cu. First one for silver E0 value is 2x, for copper E0 value is Y. Cell reaction is also given, cell representation. Cell representation you can easily remember ABC technique. Silver is anode, copper is cathode. So cathode minus anode, value of silver minus value of copper. Value of silver, value of Ag plus Ag bar Ag plus is anode, copper 2 plus copper is cathode. So E0 value of copper minus E0 value of silver, because copper acts as cathode. So E0 value of copper is Y and silver is 2x. So the correct answer is Y minus 2x. Minus 2x, option D. Next problem, if E naught of silver plus for silver is equal to 0.8 volt and E naught of H plus for H2 is equal to 0 volt. So which will act as anode and a cathode? Anode is the lowest value, cathode is the highest value. So cathode will be silver, highest value, lowest value is for hydrogen, H plus for H2. So E naught of cathode minus E naught of anode, 0.80 minus 0, that is equal to 0.80 volt. That is the correct answer.